Hello, differential equation students. As you can see, we're in Maple today, and we're going to be using this method called undetermined coefficients to find particular solutions, note the use of the word particular, to these differential equations. Notice that we're second order linear, but we're not homogeneous because we don't have a zero on the right-hand side. We'll talk in class about how to find a general solution, but right now we're going to focus on the particular solution. So we're going to find one solution to each of these equations. The idea is that we will make a guess for what the solution looks like based on what the right-hand side looks like. Since I have e to the negative t here, I'm going to guess we're going to have some constant, capital A, times e to the negative t. Now, once I've got that, I need some derivatives. So let's say dguess. And let's take the derivative of our guess function. And we need the second derivative. Once I have all these, let's plug everything into the left-hand side of our differential equation. So we want the second derivative minus 3 times the first derivative plus our 2 times our original function. And that's supposed to be equal to e to the negative t. Okay, it's pretty clear what a has to be. A has to be 1/6. So that's great. We have found a particular solution. And that's going to be y equals 1/6 e to the negative t. Cool. So notice what happened there. We made a guess based on the right-hand side of the differential equation. We then plugged that guess into the left-hand side and made the two sides equal up. So let's see what's going on down with this next one. Notice that I haven't changed the left-hand side, but I have changed the right-hand side. Let's make a guess of the form a times sine of t. There we go. First derivative, second derivative. Now when I plug that in, I have to change the right-hand side. Let's get rid of this since it no longer applies. Notice what's happening here. I look at this and I go, all right, well, I've got 5 sine of t. Yeah, so a ought to be 5. But if a is 5, then I'm going to have this extra cosine term. So we really can't solve this equation. There's no way we can find a value of a that's going to make both sides equal. So that means we've got not the best form for our guess. Since cosines are showing up, let's add on b times cosine of t. Let's see if that helps. First derivative, second derivative, plug it in. Now see that we have cosine and sine terms in here. Let's use the solve command for a system of equations. Whoops, I'm in text mode. Let's switch to math mode. You can see that the coefficients of sine are a plus 3b. That needs to be equal to 5. And the coefficients of cosine are b minus 3a. Whoops. B minus 3a, and there are no cosines on the right-hand side, so that better be equal to 0. Fantastic. Now we have our particular solution. So what we just found is that y equals 1/2 sine of t plus 3/2 cosine of t. So our basic technique is to use the right-hand side to guess the form of our solution, plug that into the left-hand side, and make the coefficients work.